Hello everyone, it's Benny, and in this video, we're going to be finishing up what we were working on last time. Because if you remember, last time what we were doing, well, we were doing a whole bunch of stuff where we were checking if the monster could shoot and intersect with the walls, and we figured that out. But now we're going to determine if the monster actually hits the player. Now if we want to know if we hit the player, then this check is going to need to be a little bit more refined. For instance, rather than just checking if we've hit the level, which, okay, we know where we hit the level, we're going to need to know where we hit the player, if at all. So we're going to need some new vector 2f called player intersect vector, or anything you want to call it. And what I'm ultimately going to do is I'm going to make one of the physics methods private in the level, or public in the level, just because that's where all of our physics checks are. And this one's going to be line intersect rect, because we're going to need to check if our line intersects the player's collider, which is, again, very manual because we don't have a physics engine. So, it's going to be line start and line end. It's going to need the player's position, which should be transform.getCamera, and the player's size, which I'm not sure if I have a good way of getting that yet or not. Is that public? Do I have some method called getSize? How would I get the player's size? Okay, I'll make it public. How about that? And a new vector 2f of player.playerSize, player.playerSize. Actually, there has to be a better way of doing this. How would I do it in here? Oh, I passed it in. Yeah, okay, I'll just do it like this then. So, we need some method for that. And there, that will tell us where we hit the player, and if. So, and now to determine, well, if we've actually hit the player, like, in relation to the level, like we haven't hit a wall or something before we hit the player, we're going to have to do some check. If that's not equal to null, so that, for instance, if we hit the player, then this can't be null. So, and either the collision vector is not equal to, and that's either null, or, and not 10 million tabs, thank you very much. What I'm trying to say here is we are performing the exact same check we did here. We're comparing the vectors. We're making sure that the player intersect vector exists, and that either the collision vector is null, or the player intersect vector minus the line start is farther away than the collision vector. I think I might have that backwards, but that's okay. I'll fix it in a moment. That line start. And, oh, right, length. We're looking for the length. I'm sorry, I'm getting a bit flustered for some reason. And am I missing? Yes, I am. Okay. Now, I'm just comparing the length of the distance to the player intersect to the distance to the level intersect. If the player is closer than the level, so if this distance is smaller than the distance to the level, so that should be smaller, I'm pretty sure. Yeah. If this distance is smaller than the distance to level, then we can just print out we've just shot the player, which is outstanding. That's exactly what we're going for. The only issue is now we need this line intersect rect method. And that can be, well, it actually will be pretty easy now that we have the line intersect method. So yeah. It's going to take in the same sort of list of parameters, but they'll have slightly different meanings. Like, for example, this won't be the lines, another line. This will be the, what should I call this actually? Now that's going to be size. Okay, fine. There, position and size. probably call it something like object pos and object size, or rect. Yeah, rect pos, because it is intersected with rect. There. And all I'm going to do for this method is I'm going to perform an intersection check with a line for every single line on the side of the rect. Okay, how about this? If this is my rect, I'm just going to perform an intersect check with every single one of these lines, figure out what that point is, and I'm just going to return the closest one. So vector 2f result is going to start off equal to null, and I'm going to return the result. And now I'm just going to have to perform 4 line intersection checks. And now, kind of like I did when constructing the level collider, I'm just going to go through line by line and perform the collision check. So, collision vector, that's going to be that. And that's going to equal a line intersection check with the line start, the line end, our rect position, and now this is going to start with the lower left corner. So, to start off with, I'm going to guess I'll just do a new vector 2f, which takes in rectPos.getX plus rectSize.getX, or well, I guess we'll start going up because that's what it said in the image, and the second one will be, oh, what will it be? rectPos.getY. That should perform the first collision vector check. And what we're going to need to do here is we're going to need to perform this same sort of comparison. So I'm going to make a private method that does that. Private vector 2f. I'll call it find nearest vector 2. It's going to take in vector 2fa, vector 2fb, and it's going to perform this check. If a is not equal to null, and either b is equal to null, or and vector 2f position relative to, how about that? I don't know, I'm just picking something. And now, the collision vector is a, and position relative to is line start. So if this, then return A. Otherwise, return B. Right? I think that's what I'm going for, right? Wait a minute. Actually, I want to kind of reverse A and B in here, because I want B to start off being the nearest, so yeah. Let's just reverse them. So that's A, that's B, that's B. No, that should be A. That should be B. And that should be B. And that should be A. Wait, no, that should be... Dagnabbit. Okay, I still did it backwards. Wait, no, I didn't right. No, never mind. Okay. So therefore, I'm just sort of mirroring this check, where A is the nearest intersection and B is the collision vector. That's what I'm going for, and I'm just going to make sure I did everything right, and it looks like I've done everything right. So, except that's always returning B, so it's not exactly much point to that. Otherwise, I want to return A. And yeah, now. So the result is going to equal find nearest of result collision vector relative to the line start. And there. And now I'm just going to want to sort of do the same check, I guess. Yeah, the same sort of check over and over again, except for different lines in this. So I'm going to copy this, and I'm going to paste it. And this time I'm going to do rect position x plus rect size dot... Wait. Rect position x plus rect size dot get y. I actually... Hang on, am I doing this backwards? I'm going to check. One moment. Nope, I'm doing it right. I'm just paranoid, I suppose. So this time I'm going to check plus rectPos.get y. Wait, no, I am doing it backwards. Dagnabbit. I need to compare x sizes to x positions and y sizes to y positions. That's the sort of secret here. So that's a new collision vector. And I'm going to perform that check again. And now, yeah, do the same thing again, except this time the line end is going, well, let me put it this way. I've done the two checks with this one. I've done the one where it goes plus y. I've done the one where it goes plus x. Now I'm going to do the ones where the end is, well, helps if I get my focus in the window. The end is rectPos plus rectSize. And if I start like this, that's just doing a line like that, which... well, okay, yeah, it's totally doing a line like that. No, dagnabbit. It doesn't do what I'm trying to say here is I don't want to check against diagonal lines. What I want to do is I want to check against, well, one of the lines... one of these. That's what I'm trying to say. There. And... so I'm just going to copy these, actually. And I'm pretty sure, I'll check off screen, but I'm pretty sure that will perform all possible line checks. And I could probably do, or store the corners as variables, just to make it a little bit nicer, but this works. So... I'll go ahead and check off screen for you. So, one moment. And it's mostly right, except I shouldn't be adding rectPos plus rectPos. I don't need to make silly typos. Need to compare rectPos to rectSize, not pos to pos, size to size. There. And I'm going to double check to make sure I haven't done any more silly typos. It doesn't look like it, but never hurts. So now, it's giving me an error. Because transform.getCamera is not a vector 2. So, okay, I'll just put this on a new line. I'll just do that over. New vector 2f, transform.getCamera, getX. Wouldn't swizzling be nice here? Oh, .getPosition.getX, even better. And transform.getCamera.getPos.getY, or Z. And with that, we should finally be able to determine if we shot the player. And it should shoot the player immediately. Okay, maybe not. I think what might be happening is we're just slightly off from the player. So actually what I'm going to do is I'm just going to say that as state equals state chase. And just do this over and over again until we shoot the player. So he's never hitting the player. Okay, then we actually do have a bug, so one moment. And I haven't figured out the issue yet, but I figured now is as good a time as any to introduce the fact that we don't want the enemy to always shoot directly at the player. I want to add a little bit of a rotation in there, you know? Maybe he's off a little bit, just a tiny bit, you know? And here's how I'm going to do that. I'm going to have some private random rand. And no, I want to import the class, thank you. And the random is going to equal a new random. There. And with every single time it attacks, I'm going to get a new random number to rotate this by. So .rotate by ran.nextFloat. Now that returns a value between 0 and 1, but I want a value between, you know, I need plus or minus, so I'm going to subtract 0.5, and that gives me something between 0.5, which is great, but I want to be able to specify how wide of an angle I want. So, public static final float shot angle equals, I'll say 10. 10 degrees. Plus or minus 10 degrees, he's shooting at the player. And unless I'm missing something, that should work out of the box. I don't think it'll make a difference because I think this isn't working right now, but yeah, we're hitting some. Oh, and we just shoot the player when we get right next to him. Oh well. So yeah, back to debugging. And I found out I don't have a bug. As a matter of fact, it's just the fact that orientation is reversed, so if I make these negative, then it's shooting in the right direction. The way it was is like when the monster was moonwalking away from me. It's just the orientation is reversed. So if I make it negative, then it's shooting towards the player. Before it was shooting directly away from the player. Now if I run, boom, we just shot the player. And yeah, although just to make this less confusing in the future, I really don't want orientation facing directly away from me. So what I'm going to do is I'm going to switch this around. I'm going to make this and move speed. Also don't want that. Whoops. Don't want to make that negative nonsense. I'm going to switch it around. And this may require, well, okay, it will require, hang on. Okay, I want that minus transform.get translation. There. Because that's just, it makes more sense the way I think about it. And now I think that the thing's going to be always facing directly away from me. Or I'll get an error. That works too. And now it should probably always be facing away from me. Good. So if I go to, where is it? Oh, where is it? Monster. It's a monster somewhere. Here. So I'm going to need to change this a little. I think if it's less than 0, add 180. I could be completely wrong. It might not be that simple. But it is! Okay! So now we've got our orientation working properly. We can shoot the player. It's not doing any damage because we don't have any health or whatnot going on yet. But we can shoot the player, and the guy can chase us all around the level. The only thing I really want to do now is it's still not checking collision against doors in the check intersections method. So I want to go ahead and do that. With the line intersect rect method, it's going to be really, really easy. But I just want to go ahead and do that real quick, just because, you know, why not? Well, that is sort of a vital, important part of the engine that we doesn't shoot for doors, but, you know, other than that, why not? So for the most part, I'm going to be doing the exact same thing I did before. I'm going to go through, okay, I can do for each loop, for each door in doors. Not doros. No, close. I'm going to perform the exact same thing here. And, oh, it's going to be door.get transform.get translation. It's going to be that. And other than that, it's going to be door.get door size. Except those are vector 3s, aren't they? Okay. Vector 2f door pos equals. Actually, I already have this calculated, don't I? Yeah, so what am I buffering with? Much easier. Now I can say door size and door position 2f. Much easier. And, you know, just because I have the method now, find nearest vector 2f, I'm going to start using that for nearest, the parameters nearest intersection, collision vector, and line start. You know, just to make this a little bit, well, reuse code a little bit. I guess that's what I'm trying to say. And I believe that's everything I need to do, so if I run, I should miss everything. Wonderful! So let's take a step back here. Okay, let's undo this, I guess. Is this not performing the same check or something? Is there a bug with this that I'm not aware of? Interesting. So if I change this to find nearest vector, and it is the nearest, it does take the previous nearest, and then, very interesting. If that is the case. Collision vector and line start. Oh, I know why. Nearest intersection equals that. Was never assigning it to anything. Now it should work fine. Excellent. So now it's working just like it should, and it's even going so far as to take doors into account. So now I don't really have a good way of testing that right now, because I don't really have much AI. I just have, well, he can shoot the player. So yeah. Well, with that, we can now shoot the player. Finally. So, that's going to be all for now, and in the next video, what we're going to be doing is we're going to be making we're really going to be sort of finishing up the AI, I guess. We're going to make the monster shoot the player like he should, and, well, who knows, maybe we can go into animation. So yeah, hope you enjoyed, hope you learned, and see you next time.